Welcome to ProfRomi series, Making the Point, Unlocking Madness Behind Methods. I'm ProfRomi, and here to explain to you why ecologists do things a certain way and then help you learn these skills. Episode 4, How to Succeed in Methods by Really Trying. Annotate statistics, write results. In this episode of Unlocking the Madness Behind Methods, we'll focus on annotations. Annotate is just a fancy word that means to add notes to, a text or a diagram, that give explanation or comment. Regardless of the course, acquiring good note-taking skills ranks very high in the factors that promote student success. Now, take a look at this cartoon, pause for a few seconds, ask yourself why it's funny, and briefly jot down your thoughts. This cartoon has both a sense of irony and sarcasm that make it funny to the practicing scientist. In addition, I find it a little sad as well, as the caption suggests that statistics are something scientists have to do versus a tool that researchers employ to make their data meaningful. While data often do not make sense initially, statistics should not be the last resort used to figure out what happened. If you look at the irony in the caption, one cannot make actual sense of the data without having done some statistics. How do you know if the average size of the bands in one column really does differ significantly from the next? Answering that question requires the use of statistics and designation of criteria for statistical significance. Check out video 3 of this series for more information on that. You may not know this yet, but running the statistics only makes up a small part of the experimental process, and scientists spend much more time planning the analyses, entering data, and then interpreting the output. In this way, annotations serve as a prompt for later writing the results. I've taken the word prompt and given annotations the following importance. Number 1, purpose. Annotating reinforces the reasons you did all the statistics. Number 2, recall. Annotating helps you organize your output so you can easily find it later. Number 3, opportunity. Annotating gives you opportunities to double check for errors. 4, memory. Statistical output all looks the same after a while, so it's good to be able to go back and review quickly. Number 5, preview. Annotating gives you a preview for what you will focus on when you write the results. Number 6, time. Annotating now saves time later. Now, we want to look at an example of annotations versus writing about results. Let's use a real-life example from one of my summer research students. Sarah did an experiment this summer that looked at the burrowing behavior of adult apple snails at 3 different levels of pH in the presence and absence of predatory chemical cues. She had 2 factors. Number 1, Q. Number 2, pH. Q had 2 levels, absence or presence, and pH had 3 levels, 5, 6, or 7. She recorded the snail's behavior and conducted 6 trials. Now that you've seen her video, let's look at her statistical output. Giving her 2x3 experimental design, Sarah performed a 2-way or factor analysis of variance on SPSS to test whether Q and pH made a significant difference independently or if they interacted. Now, I'm going to take you through her stats, how to annotate the output, and ultimately write the results. Feel free to rewind and play this next part a few times until you gain a clear understanding. Good statistics starts with knowing the null hypothesis. In this case for ANOVA, no differences occurred between treatments or a significant interaction did not occur. Here's Sarah's initial annotation. I'll read it. The interaction of pH and Q was not significant, P equals 0.058. The Q itself did not cause a significant difference in the time spent on the sand, P equals 0.953. However, the pH of the water did have an effect on the snail's time spent on the sand significantly, P equals 0.04. The significance level was measured at P less than 0.05. This is a good start, but more of a hybrid between an annotation and a result. I can improve on it in a few ways. First, I want to identify the statistical test used and the reason why. Second, I want to identify the main factors first. Third, I want to use the words reject or fail to reject the null hypothesis in my annotation. Fourth, I want to remove cause and effect words. Fifth, I want to support my sentences with the relevant p-values. Sarah did a good job here. And sixth, I want to identify what needs to come next. So here's my revised annotation as if I was Sarah. I did a two-way ANOVA to test whether pH levels 5, 6, or 7 and the presence of a chemical cue, no or yes, altered the amount of time snails burrowed in the sand. I reject the null hypothesis, p equals 0.04, that snails spend an equal amount of time in the sand at different pH levels. I fail to reject the same hypothesis for the two Q treatments, p equals 0.953. And I fail to reject p equals 0.058, but only by a small margin, that the two factors did not interact significantly. My next steps include a Tukey's multiple comparison test to test where the difference occurred between the levels of pH, and also a graph. The close p-value suggests that more replication is needed in the future. Can you tell how much more information an annotation can hold? In the example you just watched, the revision included a recap of the experimental design, a description of the variable measured, and the next steps to take. Now, having a high-quality annotation, we can move forward to write results. Having descriptive statistics at hand, or a graph, makes it easier to write the results. Instead of just saying significantly different, you can be specific and write significantly higher, lower, more, or less. Assume that Sarah graphed these results and called her graph figure 1. Pause the video again and write out the results to the best of your ability. Remember that when we saw a significant effect in pH, but not Q or the interaction, although it was close to 0.05. Well done. Now, compare and contrast your result statement with mine. Apple snails exposed to a gradient of pH levels spent significantly different amounts of time burrowing in the sand. Two-way ANOVA, p equals to 0.04. Whether chemical cues occurred or not, p equals 0.953. However, although not quite significant, p equals 0.057, we find a pattern when we combined factors. Apple snails exposed to pH 5 and 6 spent less time in the sand than those at pH 7 when cues occurred. However, they spent nearly equal amount of time in the sand in the absence of cues, figure 1. How did your result statement and mine match up? Good result statements state what happened in the experiment, support the assertions with statistics, and describe trends in a corresponding figure. Don't worry if your result statements didn't hit all the high points. It takes practice. As a cautionary word, don't follow in the footsteps of this cartoon. Creating annotations and writing results involves abiding to a clear set of ethics. Whatever you might want to happen, the results are what the results are, and statistics never prove anything. I hope you learned a lot from this ProfRomi episode of Making the Point, Unlocking Madness Behind Methods. We can summarize by comparing and contrasting, creating annotations and results once more. Annotations include 1, the statistic performed, 2, the reason why, 3, the null hypothesis, and 4, the outcome of the hypothesis testing, whether it's failed to reject or reject. Results, on the other hand, include the significance of the result, the trends in the data, references to a figure, and the supporting test statistic. From this video, you can hopefully learn what belongs in annotations and results by remembering that you write annotations for you and your collaborators, but you write results for the rest of the world. For homework from this episode, take this Tukey's multiple comparison test table, this is from Sarah's experiment, and annotate it, and then write a separate result statement. Bring this to class. Remember, the null hypothesis states that no difference occurs in the averages between treatments. As one final hint, take the last sentence of my result statement and make it more specific.